In the previous video, I showed you how to use the Raster Calculator to model elevation at or below sea level. In this video, I will show you how to model areas inundated by sea level rise at various heights. On the Humboldt State Geospatial online website, I am currently on step 14. However, just for future reference, these numbers sometimes change. When you created the model of mean sea level using the Raster Calculator, the result was a raster dataset made up of ones and zeros. The ones represented the water at mean sea level, and the zeros represented all of the land above sea level. In the next few steps, you will create models of sea level rise at different heights, the same way you created the model of mean sea level. Instead of using an elevation of 0 in the raster calculator, you will use higher numbers to represent the water rising to different heights. To figure out how much land is inundated by the rising water level, you will subtract the mean sea level raster from the different sea level rise rasters. The result will be a raster model representing strips of land along the coast that will be flooded by sea level rise. In ArcMap, open the raster calculator. This time you will enter the expression dem less than or equal to 1. Be sure to click the yellow file folder icon and navigate to your working folder. I'll call the file sealevelrise1.img. The result is a model where the ocean has risen 1 meter in height. Here, the pixels with the value of 1 represent the water, and the pixels with the value of 0 represent the land. To determine how much land is flooded by a 1 meter sea level rise, I will use the raster calculator to subtract the mean sea level from the sea level at 1 meter in height. I'll call the output inundation1meter.img. I'll zoom in a little closer so you can see the results. In this model, a 1 meter rise in sea level will impact a narrow strip of land along the coast. Remove the sea level rise 1 layer from the table of contents. You won't be needing it anymore. I'll repeat these steps to model a 2 meter sea level rise. I'll create a model of the water that has risen 2 meters. Then I will subtract the mean sea level from this model to see which areas are flooded. I'll zoom out a little so you can see the results around Humboldt Bay. As you can see, around Humboldt Bay there is a big difference between a 1 meter and a 2 meter sea level rise. It looks like areas around the city of Arcata are really impacted. Again, I'll repeat these steps to model a 5 meter sea level rise. Like before, I'll create a model of the water that has risen, this time 5 meters. Then I will subtract the mean sea level from this model. For my last model, I will use the sea level rise of 10 meters. The next question to answer is, what types of land are impacted by sea level rise? Is it farmland, residential areas, or recreational areas? In the next video, I will show you how to create a raster dataset based on land use categories.